So for section 5.4 on radians, I would be justified, strictly speaking, in saying, right, you know how to do this, all you do is do the technique from year 12, and you also label your graphs in radians, and that's it. That's all we do. Now, I'll do an example to show you exactly how that works, but obviously you can tell from that little introduction that you're going to need to know the technique from year 12, and if you've not got the idea yet, there is a video, I think it was possibly chapter 10, I can't remember, on trigonometry, where you're solving trig equations. All right, so if you can solve trig equations, you're now going to have to solve trig equations where the trig is measured, the angles rather, are measured in degrees, not degrees, are measured in radians. So I'm going to give you one example, and as usual I'll pick the same example that the book does. We're looking at page 128 if you want to follow this through. Now I'm going to do this not with the book's method but with my method, which means no cast diagrams. Again, if you like cast diagrams, I'm sure there are plenty of videos showing you how to use them, but I like to do this without, because I think it's clearer. So this time, there's my sine graph. What have I got to do differently? I've got to label this in radians. There we go. Sine theta equals 0.3. So the sine of this angle is 0.3. Oh, that's far too high. Never mind, it doesn't matter. It's just for illustrative purposes, but 0.3. So it should be a bit lower, shouldn't it? So sine theta equals 0.3. What's the angle here? Well, this is the one that the calculator will give you. Now you need to make sure your calculator is set into radians mode, and I can't give you a tutorial on how to do that on all the different calculators you've got, but I can show you just quickly on my calculator here. I don't know if you can see this, but just along the top here there's a little d. So you need to turn that little d into a little r, and I'm terrible at using calculators and I can't find the right button, but somewhere on there will be a button that will turn this into radians mode instead of degrees mode. Just bear with me 1 second while I see if I can find that button, but no, I can't find it. Terrible at finding these buttons on these calculators. But there we go. If you can find the buttons, Google your personal calculator serial number and I'm sure you'll be able to find the way to do that. Okay, so once we know that one from the calculator, and we get that by just doing sine inverse of 0.3, we've got that number in radians, and I can find that from the book. It turns out to be 0.304 radians. So that distance there is 0.304. Okay, now what about this one here? Well, through the symmetry of this graph, this distance here is the same as this distance here. So the angle that we're looking for has got to be pi take away 0.304. Okay, and that is where the second answer comes from. So we're using the same technique as we did in year 12 with degrees, only we're using it with radians. And for those of you that have the same calculator as me, I've worked this out now. If you go shift and then set up, press number 2 for angle unit, you can choose degree, radians, or another one that we're not going to worry about. So we press 2 and that little d is turned into a little r. I'm sure your calculator will have a similar thing.